Ever wondered how ancient India built structures that survived for centuries without the use of any modern technology? The roots of civil, mechanical, and environmental engineering can be traced back to India's ancient scientific traditions. Long before urban modern planning, India designed smart cities with drainage, ventilation, and sustainability. Ancient Indian engineers didn't just build structures, they built systems that worked with nature. And today, we are going to start with this amazing series in which we are going to talk about the IKS for the engineers. Yes, my dear students, from today we are going to cover the IKS syllabus of the B.Tech third semester of the IP University. And this particular subject deals with the innovations and the technological aspects that were present in the ancient time and what all today's engineers can learn from them. So let's begin this journey of ancient engineering, and we will be, by the end of this series, by the end of this whole syllabus, able to relate how the ancient engineering skills are still relevant in the modern engineering world and how we are still following the same path that our ancestors used to. So now let's begin the new chapter. In the first unit, we are going to talk about introduction of the Indian knowledge system. This is a very new topic for all of you, and let's begin with very basic thing, that is introduction of the IKS, a journey through millennia of scientific thought, philosophy and innovation rooted in Indian civilization and its enduring relevance for modern engineering practice. Now, the first question that arises in each of us minds is that what is a knowledge system? Knowledge is not raw data. It is a structured understanding refined through experience, reasoning, and context. Every civilization builds its own system for organizing and transmitting knowledge. This hierarchy, which I have shown in this slide, illustrates how raw observation becomes actionable wisdom, a process central to both ancient Indian thought and modern engineering methodology. First, we collect the data, then the information, and by the use of our knowledge and wisdom, we are finally able to give the output. Now, defining the IKS, Indian Knowledge System. Now, what is IKS? IKS is a vast interconnected body of knowledge developed over thousands of years in the Indian subcontinent, spanning science, philosophy, art, technology, and ethics. IKS is not a single text or tradition, it is a living, evolving framework of human understanding. So, IKS is not just about a mere philosophy or religious talks, it actually shows and talks about your art, your culture, even your science that was part of the ancient time. So, it is a holistic approach. Now, origin and evolution of IKS. From the Vedic period till the modern relevance, let's have a glance at the evolution of IKS. IKS was originated in the Vedic period from 1500 to 500 BCE. At that time, it was used to be oral transmission of Vedas, Upanishads. Foundations of mathematics, astronomy, and philosophy was laid down during the Vedic period. Then comes the classical period, 500 BCE to 500 CE, systematizations of the knowledge, Shastra, Sutra, Aryabhat, Panini, Charak contributed landmark works. I hope as an engineering student you must know Aryabhat. So during this time period, the great Aryabhat was born. Medieval period. The regional schools of flourish Advances in architecture, metallurgy, and regional sciences continue. By now, when we enter the modern relevance, from 1700 CE to present, global recognition of IKS contributions, integration with contemporary science and engineering education. Now, what are the core components of IKS? There is a tree of IKS who has a branch, and each branch have different fields. Now, there are Shastra, there are Ved, there are science and technology, as well as art and culture that are part of your IKS. Now, the scientific nature of IKS. Ancient Indian scholars followed a rigorous methodology, striking similar to the modern scientific method, grounded in observation, logic, and verification. The core was application, over that is logic, then experiment, and the outermost is the observation. From observation to application, we could actually see how the process of applying a new logic or a new thought works even during the ancient time. Now, the fields that are covered in IQS are astronomy, mathematics, Ayurveda, architecture, and metallurgy. Now, IQS versus the modern knowledge system. Both frameworks offer distinct strengths. Understanding their differences reveal opportunities for integration and richer problem solving. IQS was a holistic overview, whereas modern knowledge is specialized disciplines. IKS was sustainability first, whereas modern knowledge is industry driven. Oral and textual transmission was in IKS, whereas digital and experimental is a part of the modern knowledge. Ethics integration was part of IKS, whereas ethics separate domain is accepted in the modern knowledge. Community centered was IKS, whereas individual achievement is about modern knowledge. Cyclic time and linear progress are respective differences of IKS and the modern knowledge. Now, IKS offers systems thinking, ecological awareness, and ethical grounding, whereas modern science offers precision, scalability, and technological acceleration. Together, they enable sustainable, culturally informed engineering solutions. Why ancient knowledge matter today? It was sustainable, cultural identity and innovation was there. Plus, ethics was highly induced into the ancient knowledge. 300 years of traditions, 50 plus Shastra text, and one unified framework. This is how the ancient knowledge system was packed in small textbooks or were passed on through generations. So, these are the four pillars of the ancient knowledge. Now, why you guys, you engineers, the upcoming youth should study IKS? First, it enhanced problem solving. Second, sustainable design. And the third is indigenous innovation. IKS is not a replacement for modern engineering. This is something we should always be clear about. It is a powerful complement that broadens your design thinking, deepens your responsibility as an engineer. If we inculcate, if we actually integrate both the IKS knowledge as well as the modern knowledge, the outcome would actually be very different than what we have right now. The number of failures or the number of setbacks that we experience might be less, or we would be able to come with a different thought process entirely. Now, let's have a look at some ancient engineering examples. The stepwells, the famous Bauli system, the temples, ancient temples of India, and the iron pillar, the famous rust resistant iron column, showcasing advanced metallurgical knowledge, are some of the ancient engineering examples. And I hope you must know that even today we are not able to find the rust resistant irons, but 1600 years old scientific minds could actually found a formula that is able to make rust resistant iron. Now, IKS in mathematics, zero decimal system and algebra algorithms are some of the greatest contributions of India to the world. These were actually discovered and derived in India, and the world now enjoys it. So, this is how IKS was in maths as well. We will talk about it in deep in the upcoming classes. IKS in astronomy, not just mathematics. Aryabhat, Surya Siddhant, Nakshatra system were well explained. Aryabhat explained everything, even at that time when there was no modern telescopes or even without telescopes. So that was how advanced was the IKS. Even during that time, we were able to see the distance between the planets, the distance between the sun and the earth. This is some of the marvelous facts that IKS stores. IKS in medicine, not just maths and astronomy. IKS is also available in the field of medicine. The famous Charak or Shushruth, Charak in the medicine field and Shushruth in the surgical field, are two famous doctors who were there in the ancient time and could perform surgeries even without the use of any modern surgical tools. So that was the advancement of IKS. Pulse, tongue, prakrit assessment. We could actually find the disease using these three parts of the body. Now, sustainability has always been an important part of the IKS. Nature, use, balance, and recycle are the core components of the sustainability in the IKS. Now, how the knowledge transmission was happening in the ancient time. There used to be a guru, a teacher, and there used to be a sishya, a student like you and me. But here I am your guru and you are my sishya. So let's take it up like this. Like I am your guru and you guys are gaining the knowledge. So you guys are the sishya. I am telling you something about the IKS and you are learning about IKS from me. Then you practice this thing and then after some time you actually master this knowledge. So this is how the transmission of knowledge was done during the Indian ancient times. Now, why is it relevant in the modern engineering? IKS offers proven frameworks that align with cutting edge engineering challenges, from sustainable materials to system level design thinking, green technology, smart materials, and systems thinking. Green technology, passive cooling, natural ventilation, water harvesting, and this inspires sustainable architect, whereas a smart material, ancient alloys, composite informs, modern corrosive resistant and self-healing materials. System thinking, holistic IKS framework, mirror modern integrated design, and circular economy principles. Why it was their challenge in understanding the IKS? First, it was the language barrier. India is home to many different languages. Primary ancient texts were found in the Sanskrit languages and some regional languages as well, which is still untranslated or inaccessible. Lack of resources, few digitalized manuscripts, interdisciplinary programs, or dedicated research funding. Misinterpretations, decontextualized readings, and colonial bias distorted original knowledge intent. So, some of the reasons why challenges are there in understanding IKS are these. Now, why IKS is introduced in the NEP 2020? First, it is in your curriculum, it will enhance your skill, it will help innovation, and after research, you will be able to actually see how, even before the time you were born, or even before thousands of years, scientists and engineers were able to give better outputs, even what was able to tell what you know today without even modern tech and tools. So how was that possible? अगर हमें पता चल जाएगा, so it would be amazing. हम आज उसको यूज करके काफी आगे का सोच सकते हैं. हमारा इनोवेशन बढ़ जाएगा, हमारी क्रिएटिविटी एनहांस हो जाएगी. So that is why the government has introduced IKS in your NEP. Now, to conclude, I would say IKS is not a relic. It is a living knowledge system with direct relevance to the engineering challenges of today and tomorrow. Past, zero, Ayurveda, step wells, iron metallurgy, astronomical models, whereas present is the NEP, integration, the green tech, the system thinking, and material science. Now, with the IKS in our syllabus, the future would be IKS informed innovation, sustainable engineering, global knowledge equity. Integrating IQs into engineering education cultivates innovators who are technically skilled, culturally grounded, and ecologically responsible. So, this is why IQs is integrated into your syllabus with the hope that, with the help of the ancient knowledge and your present modern skills, we as a nation would become even more modern, even more developed, and we would be able to decipher the undiscovered innovations, undiscovered facts, and undiscovered technology. So let's hope that by the end of this series, we would actually fall in love with the ancient Indian knowledge system and we would actually work in deciphering what all is stored in our ancient past. So that's it for today. We have started this new series for the B.Tech students, and I hope you love this. So show some love, spread the word by sharing, and join our channel by subscribing. Comment and share your thoughts, how you would like us to proceed further. We are going to cover each and every topic of each and every units. So let's face this new subject together. Let's make this easy for all of us and let's crack it and get even better, become even better engineers. So we'll meet in another class with a new topic and on a new day. So till then, take care, keep studying. Bye bye.